Welcome to the third video in a series of 8 on rational expressions, multiplication. Before we can get started on the actual problems that you're likely to see in a course, I have to present an idea that I call the interchangeability of factors. Here's an example. This is not, by the way, the kind of problem that we'll be doing for the most part in this video, but this problem is just here to convey an idea. So I took this product of fractions and I worked it out on a calculator, and I got about 6.49 roughly. But then I took a similar problem using the same factors but making a single fraction, and my calculator gave me the exact same answer. And then I interchanged those back into a product of two fractions, and my calculator gave me, again, the same answer. And that just shows me that these three expressions are equivalent. And the idea here is this. As long as your factors in your numerator all match, and the factors in your denominator all match, then rearranging or interchanging the order of the factors, or which fraction they appear in, will not change the final value of those expressions. How will this help us? Well, suppose we have a problem like this. Using the interchangeability of factors, I could rewrite this expression this way. Now this may look different, but notice the factors in the numerator are the same in a different order, and the factors in the denominator are also the same in a different order. Now why on earth would you want to rearrange the factors, the order of the factors, within two fractions? Because you'll notice at the bottom expression here, I have a factor divided by itself. And essentially, anything divided by itself is 1. And then anything times 1 is itself. And so, using that idea, you can see how the interchangeability of factors could create a fraction whose value is 1, and thereby simplify the expression. Now this isn't a full problem, but this was just designed to give you an idea of why it would be super helpful in some cases to rearrange the order of the factors. Here's our first example that is a typical kind of problem that you would see in a mathematics course. So, how can I use the interchangeability of factors to simplify this? Well, I don't have any factors at all here, so first I'd better factor everything, which is what I've done here. Now, if you saw the previous video, you'll notice that I use this pause symbol as a reminder to you that you may or may not want to pause at these points and do all of the factoring work yourself. These videos all presume that you have enough factoring skills to get through the rational expression problems. And so what I'll do throughout this series of videos is I'll simply say, oh, all this stuff factors, and I won't explain or show any of the factoring work whatsoever. It would greatly diminish the quality of the video, so I won't do that. But what the pause symbol is there to remind you is that if your factoring skills need a little work, or you just want to slow down and see that everything factors the way that it does, then these would be good places for you to pause. So now that I've factored everything, how can I interchange those factors to my benefit? Well, one way I could do it is this way. Notice I haven't changed the mathematical value of the expression because all the factors in the numerator are the same in different orders, and likewise the factors in the denominator are the same. But notice I've arranged them in such a way that my last two fractions both have a value of 1. Anything divided by itself is 1, so I can change those last two fractions into 1s. And then using the fact that 1 times 1 is 1, and then 1 times anything is itself, those 1s essentially vanish. And that gives me a simplified version of this multiplication problem, and effectively the answer to the multiplication problem. Now, there's no general agreement over whether answers for problems like this should be expressed in factored form as it is here. That answer is 100% correct. Or whether they should be expressed in expanded form. And if you pause for a minute, you'll notice that I simply used FOIL on the numerator of my first answer to get the numerator of the second answer. And this answer is also 100% correct. There's no general consensus among mathematicians which format to leave the answer in, factored form or expanded or standard form, and so I'll leave them both there and let you choose. But neither is better than the other for the most part. Here's another example. This one's a bit trickier, but I'm going to follow the same general guidelines. The first thing I'm going to do is factor everything. Oh, you may remember that we saw this problem in a previous video where I claimed that the answer was x minus 5. And now you'll see the work that shows that. So the first thing I'm going to do is factor everything. Pause if you need to see each one of them separately. And then I'm going to rearrange the factors. Now this may look completely different to you, but all I've done is rearrange the factors in the numerator and rearrange the factors in the denominator, and I've grouped all of these into fractions where I have quantities that divide out to 1, or in some cases, in this particular problem, negative 1. Watch and you'll see. First of all, this is called the division of opposites. I also called it the division of reversed subtractions. And we saw in earlier videos that that has a value of negative 1. This clearly also has a value of negative 1, and this is obviously 1. So you can see by my clever choice of rearrangement that I got a lot of 1s and a couple negative 1s out of this. Well, first of all, negative 1 times negative 1 is 1. I could multiply those. That effectively gets rid of the negatives. And now, taking this expression on the bottom, what I've got here is x minus 5 being multiplied and divided by 1. Well, multiplying and dividing by 1 don't change the value of anything. Therefore, this whole expression simplifies to x minus 5. And you can see that we did indeed get the answer that we saw in a previous video. Here's one more example. If I want to multiply these fractions, I would find it much simpler to factor everything first and rearrange my factors. Here's my factors. Pause if you need to. Now something caught my eye here. I noticed that I had different powers of the same factor. And so I thought for rearranging purposes, it would be smart to express x cubed as x squared times x. Now that may seem like a strange choice, but what it will do in the next step is allow me to pair up these into a single ratio that will become 1. And that was the reason for me choosing to express x cubed as x squared times x. Now after rearrangement, and again this may look completely different, but it's just a rearrangement of the factors. Notice that I've grouped the factors into ratios that will give me 1. The last two fractions here, the x minus 4 over x minus 4 and the x over x both have a value of 1. And using the fact that 1 times anything is itself, I can omit those. Now I still have two fractions to multiply here, so I could multiply them together by effectively just physically putting them together. And we're getting close to an answer here, but look at the denominator. The denominator has a 1 times something. That looks a little sloppy. Let's get rid of that 1 on the fact that 1 times anything is itself. And now this here is effectively a correct and final simplification of this original product. Although traditionally, we would take the x squared and the 2, since they're both monomials, and multiply them together. That's not a rule that you have to do that. It just looks cleaner to the average mathematician if we put the monomial factors in front of the x plus 7 binomial. Again, it's not mandatory, but it looks nicer. And that is essentially what I would consider a simplified answer and the final answer to this problem. It's not generally agreed upon whether or not we should distribute the 2x squared into the parentheses. In other words, it's not agreed upon whether we should leave the answers in factored form or standard form. Either one is fine, and none is better than the other. Okay, let's summarize the main ideas of this video. You'll be given a rational expression times another rational expression. You'll factor the rational expressions. These capital letters represent prime polynomials, factors essentially. After factorization, you will look for like factors and rearrange or interchange the order of factors so that the like factors appear in ratios of that equal 1, something over itself. You'll use the fact that anything divided by itself is 1 to get your final answer to these problems. And that completes the third of an 8-video series on rational expressions.